Hello everybody, Dr. Metzger here, and today we're going to do Lab 9, which is using static. So what we're going to do is kind of go over the different uses, such as using it as a local variable, using it as a global variable, using it as a member variable, and using it as a member function. And specifically, we're going to write some code that demonstrates the meanings of 1, 3, and 4, but I'm going to demonstrate all of the meanings. Okay, so we're going to switch here to Visual Studio, and I'm going to go ahead and just write some metadata up at the top of my program. All right, so there's some handy information at the top of the class for us, and there's a few headers that I know I'm probably going to want to use. IOStream, IOManip, and string. So let's write our main function here. So we can get started. Okay, so I like to write a little checklist at the top to kind of make sure that we're doing everything. So we want a static local variable, static global variable, a static member variable, and a static member class or function. Okay, so those are the steps that we would like to use. So we just do create initial program for Lab 9. So we'll commit our changes and let's go ahead and get started. So for a static local variable, we'll call it foo static. And basically, if we were to have like a regular member variable, it would be, int initialized. Let's say it starts out as 0, and if not initialized, then we will go ahead and print a message. All right, so there's our first one, and what we have going on here is that this is a special definition that gives us the name of the function that we're inside of. All right, so it's a macro variable. So if it's not initialized, then we're going to say, hey, it's not initialized. We're going to set it equal to 1 so that it is. And then under else, we'll do something called, and let's just print out the number of times that the function's been called. Sounds good. Maybe we'll even just call it count, just for the sake that this code down here looks a little bit better. All right, so, and then when we are done, we'll increment count. All right, so if we were to call foo static, we'll call it 3 times. And if we were to run this, so I'm going to press F5 inside Visual Studio. That's going to compile this, and we're going to go ahead and run it. All right, so we can see foo static is not initialized, foo static is not initialized, foo static is not initialized. All right, so that means that we can't actually see the function doesn't work the way we'd like it to. We'd either have to declare a global variable, which we generally try to avoid, or we can use the static keyword. So if I were to define foo static the variable count as static, then this will actually work the way we want it to. So after it's finished compiling, we're going to see the program come up, and we will see foo static is not initialized, foo static called 1 times, foo static called 2 times. And so we can see that this works out just the way we'd like it to. And so if we had some, earlier we talked about initialization, and we had some initialization we'd like to do first, then we could do that and then set it to 1, so the next time the function gets run, we won't have that problem. Okay, so we are going to go ahead and mark that. We're going to check that off. Okay, so let's check our code in. Static local variable. So commit that, make sure that's saved, and then we're going to talk about a static global variable. All right, so for a static global variable, we have 2 choices here. We can either initialize this when inside a anonymous namespace. So an anonymous namespace is one with a namespace without a name, and let's just say we have an object inside of this, and which we probably need to write. We're going to write an object real quick called, we'll call it test static, and inside the constructor we are going to print out test static. Well, we could actually use the function keyword as well. And we are going to want to use a static global variable to represent the count. So let's go ahead and put a static global variable up here. Initialize it with 0, called test static times. All right, and then we will go ahead and increment that at the beginning. And then when we're out, all right. We are, let's do another thing as well. Let's put this number inside a private member variable. And then when we initialize the class, we will use the static count as the static function instance num initialized. That sounds better. I like that. So we'll say we'll allow the function to keep track of which number that it is. All right, so there's our first one there, and then we also want to say when it got destroyed. Okay, instance num. There we go. So we have a test object here. When the object constructor gets called, it's going to report the instance number, and when it gets destroyed, we'll get to see that number as well. Okay, when we initialize the static global variable, it'll be 0, and we can actually do this inside of here as well. We'll have static test static, we'll call it TS, and so this object will be called the first time. So we should be able to see when the constructor gets called, and the fact that there's only ever one of these objects. But we'd like to make sure that does this get initialized at the beginning of the program or when foo static gets called the first time. All right, so let's print a message out here. Starting main, and let's do another one. Leaving main. All right. So let's see what happens when we run our program. We should, now that we have test static, we should see the numbers acting appropriately. So when we start main and we call foo static the first time around, we see that test static, colon, colon, test static, so object 0 is initialized. Okay, and then when we leave the main function, then we see that that object that we initialized inside of foo static finally gets destroyed. So let's go ahead and add, a function inside of our anonymous namespace here. Let's add ts1 and ts2, and let's see what happens when ts1 and ts2 get called. Let's see if they happen before the main function gets called or the first time the main function gets called. So we can see here that test static 0 is initialized, test static 1 is initialized, then the main function gets called, then we call foo static. That's when the third, or instance test static 2 gets initialized. And when we leave main, then we notice that they get destroyed in the opposite order. So 2 gets destroyed, then 1, and then 0. All right, so that's how that kind of unfolds. And that kind of, let's go in here and just kind of check to our numbers here. So our steps here. So static global variable. We saw it in two ways, using just static as a global variable, and also as using an anonymous namespace. Now, because we're of this anonymous namespace and declaring the static, it doesn't matter if we were inside a different C++ file, those variables would not be accessible at all from those other link units. So this is called internal linkage. So let's go ahead and check that code in. So this is lab9 static global variable. All right, now let's do the static member variable. So here's our test static class. And if we wanted to have a member variable, we'll call it, I guess we'll make this a test. We'll use an object, so a standard string class, and we'll call it class name. All right, so because we declared this static, if I was to compile this right now, you'll notice one of two things. For one, I cannot initialize it, so I cannot do this. We will get a compile error. So if I try to compile this, it says that class name, test static class name, is a static data member with an in-class initializer, and it must have non-volatile, let's see here, const integral type, or be specified as inline. So it's okay if it's an integer, but it's not allowed to be an object. So we'd have to, in order to fix that, we have to declare this outside of the class. So here's our definition, test static class name. So that's a declaration. This is the definition. So we compile this now, and we see that this is just fine. Okay, and we could even do a little test here, that when we call the constructor, we could maybe we could try and set the class name up so it's a different function. So I might need to include string stream, and what we're going to do here is I'm going to make an ostream stream, and let's go ahead and we'll call it test static, and then we'll put the instance, our instance num, and then we'll go ahead and set class name equals to our string. All right, so we're just going to make a little string here, and then let's have the ability to print that out. So if I print class name, if I make a little function here that prints this member variable out, then every time let's say we call foo static, we go ahead and call ts.print class name. And let's try to do that in here before we call. So we have ts1 print class name, ts2.print class name. And then last of all, we'll call ts1.print class name again. And we'll see what happens to this variable class name when we run it. So I'm going to hit Control F5, compile it. And when the program runs, we will see over here that test static 0 is initialized, test static 1 is initialized. When we call our main function, you notice that we have test static 1, which means that we're talking about this instance. This is the last time it got touched. That's the last one that we'll see. So when we call test static 2 is initialized, we see that we're using the static variable inside foo static, and now that class name is updated to test static 2. So finally, when we leave, we see that that one variable has been updated. So now it says test static 2. All right, so that is a static member variable, only used one time. So let's go ahead and check that code in. Lab 09 commit all. Last thing we want to test is a static member function. A static member function. So what we'll do here is we'll just define this as void print class name, just to show you that technically it could be the same. It could be the same class. Let's see if we can put the definition inside the C++ file. So standard cout. We'll just prefix this so that we know which one we're in. And let's see if we get any compile errors. Oh, we do get lots of compile errors. Okay, so for one, class name is not a member of test static. So let's see if that was, it is right there, right? So that's not, then we see class name here is a redefinition, undeclared identifier, cout symbol cannot be used in a member using declaration, all sorts of errors. It means we definitely did it wrong. So we're going to go ahead and we're going to take this definition out. Maybe we'll just check to see if it has something to do with the name. So if we were to compile this again, and yep, so can't use the same name. All right. Now let's see if we call it from. We'll call it from over here. We'll call test static right class name. So we should see the static right there. So static test static 2, static test static 2, static test static 2. Okay, so that gets called appropriately. Oh, don't want to pin that. Okay, so that's how you access this static method. Okay, now let's see if we can use it to access. Can we use it to access, say, instance num? So if we had cout here and we try to print out instance num, this is not a static member variable. Okay, and we compile this, then we will get an error, illegal reference to non-static member instance num. Okay, so there you have it. You cannot refer to these non-static members. All right. Now, but we have seen over here that you can access a static member in a non-static member function. All right. So generally it's flexible unless you can't, we don't have access to this variable. Although theoretically, if we had passed in, we could write a static member function. And let's say we passed a const reference, const test static. We wrote a static member that can, should we just copy? And instead of over here, we can pass in a test static object, and we can access this, and it's private. So we were talking about using the friend keyword. In some cases, you can avoid that. One way to avoid it is by using these static member variables. So if I was to call foo static, and we called write class name, but instead we passed our object instead, and we ran this, then we will see over here that when we call static, there's instance 2. Well, we're calling it 3 times, but what we probably should do is call this in the main function. So let's actually take that code out of there, and let's call it on our main function. We'll do it at the end. So we'll pass in ts1 and ts2. All right, and let's go ahead and run this program. All right, and so now you can see at the very end, static instance 0, because that's the very first one, and static instance 1. All right, so we basically were able to avoid using the friend keyword by just using a static member function instead. Okay, so definitely a useful way of using static member functions. They can help access, we can help do the access control. So let's go ahead and check this off. We have tested static in a member function. All right, so you go and try this out. Make up your own class and give it a context, and use the static keywords in at least, you want to make a static local variable, static member variable, static member function. All right, those are what you need to do, write code to demonstrate those meanings. All right, well, thank you very much for watching, and hope you have a good day. Take care.